Hello, y'all. Is Tim Nudd here, and welcome to this homework assignment for lesson number 10 in the most excellent Pico W tutorial series by Paul McWhorter. And this is a different background than you're used to seeing. Usually I'm in my truck making these videos. But as you noticed, some of my videos have been delayed. I've had different family emergencies I've been dealing with, and kind of made the video and tinkering time slower. But I took a couple days vacation and had some extra time and needed to get this video out because, well, it's Monday and tomorrow is the new lesson coming out. And I don't like falling behind. I'm trying to get caught up. But anyway, this is a beginner-based homework series using only what has been shown thus far in the lessons. I guess eventually I'm going to do I want to do a video of my electronics shop here. Which, as you can see, I've got CNC router back there. I've got under all this stuff, and I apologize about the mess. I was not planning on making videos in here yet. And, well, I wanted to, and it was easier here than doing it in the truck while I was home. So we're doing it here. But anyway, I got a diode laser here, the CO2 lasers in the house, because I just have a window AC unit in the shop and a couple little space heaters for the wintertime. And water likes to freeze. The laser tube is water cooled. And I really don't want to spend the money to get a new laser tube because it busts. So we have that in the house. Proper ventilation, filtration system, everything safety you needed there. So don't worry about all that. But it's kind of my tinker work on everything shop. It's a diode laser, got a CNC router back there. I got a pyro printer that you can't see. You kind of see another one of my little projects here, which I'll get out of the way so you can see it real quick. It's a 1967 Harley Ironhead Sportster, hardtail, right-hand suicide shift. I've had it a couple weeks. The engine does run. I got to go and rebuild the carburetor though, and redo the brakes front and back, new lines and calipers and pads, because well, that's kind of important when you're on a motorcycle to be able to stop. Being able to go is awesome, but you kind of want to stop when you need to as well. Eventually I'll start making some other videos out here, some other tinker projects. I also, with my electronics out here, I'm currently working on, very slowly and behind, but I'm working on an 8-circuit board software-defined transceiver. If you want to find more information about that, it's the T41 EP project. I'm working on that. A lot of surface mount components, and it's based on the Teensy 4.1 microcontroller. I think it's 15 or 16,000 lines of code right now. I'm not writing it. I'm building the radio and using the code that they built for people to use. I'm not that proficient yet, but I will be doing some modification for it eventually as well. That's why it's an EP experimenters platform. It's designed to be modified, and it'll have a 9-inch touchscreen display on it. And eventually, I'll probably try to do some videos on those at some point, and a little tour videos at some point as well, showing all the test geared that I have in here. And I really need to do one about the studio and the truck and what components I keep in there to tinker with when I'm on the road. But anyway, I need to get to this lesson's assignment because it's probably going to be a little bit longer of a video. Uh, the assignment this week is to create a dimmable LED using a potentiometer, the analog to digital converter on the Pico W, and pulse width modulation. The potentiometer is all the way to the left. LED is off. All the way to the right, it's on, full brightness, and then scaled dimming and brightening in between. Well, we kind of covered that in our last week's video, when we went ahead and kind of did this week's homework without even knowing what this week's homework was going to be yet. So we'll briefly do this week's homework, but then we're going to expand like we did last video, and we'll just put out a little teaser that it has something to do with Big Boogie Face, or BBF in there, and one of the things that he likes. So we will we'll leave that a little later in the video. But first, let's get building the homework assignment, and then we can get playing on our extracurricular activities there. So first, we need to, well, not need to, but I want to. Let me go ahead and bring up the pinout here so I can see that as well. Alright, so physical pin 38 is ground, and 36 is 3 volts out. So I want to get those rails powered up. We'll need that for a potentiometer. And I'm going to cheat because my big fingers don't like to pick these little things up quite so easy. These are very, very handy. If you don't have some, I would highly suggest getting some. If there's an interest, I can give a link to where I got them from and all that, but I digress. Alright, so we got our rail set up. Now we need to set up our potentiometer and our LED, and then we'll do the code. And I'm going to use, for this one, I'm going to use ADC2, which is GPIO pin 28, physical pin 34. So that is, I got 2 pins below the voltage out. Positive voltage will go there. And we'll set that there. Let's set up our positive. Actually, let me pull this up a minute so I can put this underneath it. Set up our ground is on the left, and our positive voltage for potentiometer is on the right. So we get these in the right place. And let's set our potentiometer in there. Now let's get our LED set up. And I'm going to use, for this one, because I'm leaving space for for later parts in here, we're going to use GPIO pin 11, which is physical pin 15 for our LED. That started at there. Let's put that here. And then, since we have a ground rail up here, we'll set our ground, our long leg toward the positive. And let's put our current limiting resistor in here. That should be, that's our potentiometer LED. Let's get over to the code and get that done real quick so that we can get on to some other even more fun things. Let's make sure this part works since this is the homework. Doesn't matter, we covered it last week. Homework assignments for this week, so we're going to do it this week as well. So first, we need to do our usual import some libraries from, if I can spell, machine import. We're going to import PWM and pin. And then we need for our delays from time import sleep. Alright, now let's set up our LED. We're going to go LED 1 is equal to, we set that on pin 11. Now we need to set up the PWM portion of it. So LED 1 is equal to PWM pin, and then what pin we called it, LED 1, and close both of those. Now we need to set the frequency. And I'm going over this fairly fast because we did this last week as well. Frequency, we'll use the trusty 1000. And now we need to set up our duty. Duty, it's an unsigned 16-bit. And we're going to set that at 0. We'll be changing that in the code later. But for right now, we'll set it 0 so it's off. Alright, now we need to set up our potentiometer. So we're going to do delay pin is equal to... no, that's delay. I just gave you a hint as to what we're doing later. Anyway, I'm getting ahead of myself here. Dim pin is equal to, we set that on 28. So we need to set the ADC part of it up. Pot is equal to machine dot ADC or ACD. No, and I did it wrong again. ADC, and that is we're getting that is from our dim pin. And let's set our delay up here. DT will do 0.25 for this part. We got our delay time, so we got our LED set up, our potentiometer up in the top. Now I think we need our while true. If I could actually spell or type, I guess would be more accurate. While true. And then now we need to set up, let me get our, well, let's first dim val. We got to set that to, or tell it where we want to get our dim val from. And that is from pot, which is ADC dim pin. So we do pot is equal to pot dot read, and it's an unsigned 16. And we'll just open close that because we're reading from it. We're not assigning it a value. You're saying that's what we're getting that from pot. Now for our get our voltage. I'm not going to go in depth into this. Paul does a lot better job explaining it, but this is the math we use for it. Very similar to what we did last week. We're going from 0 to 3.3 on the Y and 0 to 65,535 on the X axis. And but we'll use in this formula here and here. So we need to do set voltage is equal to 3.3 divided by 65199, and it would help if we did it kind of properly here. These are parentheses, and times our dim val, and then subtract. Need to 336 times 3.3 and divide that by 65199. That should get a set voltage 3.3 divided by 65199 times dim val minus 336 times 3.3 and 65199. Alright, that should be good. Now we need to get our PWM val, which I did on this side of the paper. And to get that formula, because we're doing 0 to 3.3 on the X and 0 to 65,530 or 65,550 on the Y. We're using this formula here. Sorry, it's kind of hard to see. PWM val is equal to 655. Let's use our parentheses. Excuse me. 65550 divided by 3.3, and then we'll times our set voltage. All right, so we got that. That part should be good. Now we need, let's print so we can see what our value is. We'll print voltage equals, and then we want to print set voltage, right? Yes. Yeah, PWM val, yeah, set voltage. And let's see, so set voltage. That should be our print. So that'll tell us what. And let's do a little, have a delay so it's not spamming it there. Sleep equals DT. Alright. So that, now we got to set up our LED. So, well, we already set up our LED, but we want to, so it'll tell the LED what we want to control. So LED duty, remember I said we would set it to 0 there, but we're going to control it down here. And this is where we're going to control it. LED duty, it's an unsigned 16-bit. And then that is, we want to use the integer value of PWM val. And close both of those. That should do it. We got our LED set up, our potentiometer, delays. Let's see if we get any anything on this. Okay, ADC has no read. But that read, U16. That will probably help. There we go. Now we're getting voltages here. Actually, why did, let's actually move this under here. That is moving way too fast. Not giving us what we want. Alright, that's a little better. So now as we go to the right, or to the left, we should be. But why are we not getting any voltages here? Alright, what did we do wrong? Yeah, we did. Set voltage. Okay, times dim val. Do we not have something hooked up properly here? Getting a reading, but it's not really changing anything. Get our positive or negative. I think should be. Let's try up here. Let's stop it. And restart it. There we go. I don't know what was wrong there, but might just been a loose connection. Now we're getting these values. As we go to the right, it gets brighter and brighter and brighter till we're at full brightness. Getting our readouts there. And we go left. It's harder to see on the camera in here. It's getting dimmer and dimmer and dimmer. See if I can block some of the light maybe here. Yeah, go up, down, dim this off. Alright, good. Now we got that part right. So, let's let's add the next parts of our project in. Let's go back to our circuit build. And we'll get into this part here. So, let's set up our other potentiometer, because, well, I gave you a hint earlier. It was, has something to do with Big Boogie Face. He loves Larson scanners. So, we're going to put 4 more LEDs, make 5, make us a little Larson scanner, where we can control the brightness and dimness of that. But we're also going to add a second potentiometer in to control the delay. And that way we can control the speed of how fast it's going back and forth, as well as independently controlling the dimness of that of the flashing LEDs. Now, a little disclaimer, this is very brute force approach the way we're going at it today. There are much better ways to do this. This will work. It's not the most responsive, it's not the best, but we haven't gone over a lot of the other features and parts of that to go on. Some other point we'll may revisit it and make it more efficient and better. But we're going to do the full brute force version of it today. So that being said, let's get our other potentiometer set up here. I'm going to put our, use this here. Let's get our, this goes to positive, set that there. It's probably a good idea. We'll see, hopefully nothing bad happens, but it's a good idea to power down your Pico W while you're building circuits. And I'm not even listening to my own advice, but actually, yeah, you know what? We're going to do that. Just unplug, and then we will alright. Just going to do that. Oh, now it's going to keep getting in my way. Alright, fine. We'll do it the hard way. Or the way we shouldn't do it. Anyway, do as I say, not as I do. And I'll probably bite me later, but... Anyway, so we're going to use, for our delay potentiometer, we're going to use ADC0, which is GPIO pin 26, physical pin 31, which should be 1 to 3rd pin down from where our other one. Now let's put our potentiometer in here. We have that hooked up. Alright, now let's add the rest of our LEDs in here. Try to keep them kind of spaced evenly if we can. Remember, long leg goes toward positive, short leg goes to ground. And let's go there. And here. Alright, now let's get our current limiting resistors in. And I want to put them the same way that I put the other, just because I'm OCD. Or if you want to get actually correct, CDO, so it's alphabetically in order. Doesn't matter which way you have the resistors facing. Honestly, they will function exactly the same, no matter which way they're put in. But I like having things uniform. So, now we're going to connect them in order using pins, GPIO pins 11, 12, 13, 14, and 15. So that's 11. And then, oh, excuse me. Do 12. for our second LED. And then 13 for the third LED. And yes, I kind of did that on purpose. 11 equates to 1. 12 is 2. And 3 and 4 and 5. So then 14 is going to go to LED number 4. And GPL pin 15 is going to go to LED number 5. I think I have those hooked up properly. We will find out. Sure, let me adjust this one a little bit more here. Get a little bit more in the hole. Make sure we get good connections. Alright. Think we have our circuit set up there. Properly anyway. So now we need to go do a little more coding. Alright. So we have now we need to set the rest of our LEDs up. So I'm going to try to make it go a little faster. Control C. I'm going to set the rest of these up. B. Now we'll go and it's 1, 2, 3, 4. Alright. Now let's change. This is LED 2. It's going to be 12. It probably would have been faster just type it out. Less likely to get errors, but if we get errors, then we will go back and figure it out together. Get all these changed properly here. That should be 4, LED 4, 13. Make sure to change everything, or alright, so that's there, and they should be 5. Alright, so that there. Now we need to set up our, in between there. Now we need to set up our delay pin. Delay pin is equal to, put that in GPL pin 26. And same pot, and then we'll call this one pot 1, so it doesn't confuse the delay and the speed. We can do them independently. Pot 1 is equal to machine.adc, and that is coming from delay pin. And now we need to actually, since we're going to be controlling delay down there, we need to just leave that at open because we're going to be reading it down here. So now we need, since we dim val, now we need to set up our delay val. Delay val is equal to pot 1 dot read underscore unassigned 16, and we're going to set that like that because we're going to be reading that from the potentiometer. Now for the little bit of math, it's very similar to this. Instead of, all right, come on, focus, there we go. Instead of 0 to 3.3, I want to go 0 to 0.15 for the delay. So we're using the same value here. So basically all we got to do is short without writing this out again is change 3.3 to 0.15. So it's very similar to our PWM val, except this is going to be our delay val, or actually our DT. So DT is going to be equal to 0.15. Actually, no. Or is it? Should be based on that math. Let's try it. We'll switch it back if we have to. Somebody just stick in my head I did it the other way. 65550 divided by 0.15, and then multiply that by delay val. I think, I don't know, it may be backwards. If it doesn't work right, we'll switch it and go from there. So let's, we got that set. Now let's print, oh, not capital. And I'm leaving that in there so it'll be a space in between them to help differentiate from running together there. Go delay time equals, and then that's going to be our DT. So we're going to print DT. All right, that should do that there, and then give us a little little space in between them. Think that'll work. All right, everybody can see this properly here. Now we need to set up the rest of our, to make it do it, like I said, this is very very brute force way of doing it. There are much better ways, but since we have 5 LEDs, we do this 5 times. Okay, and then we change this to LED 2, LED 3, oh, LED 4, LED 5. Okay. Alright. So I want to have these completely bright first. We'll just test our circuit with this, and then we'll make our changes in here that we need. Think that's what we need. Let's hit run and see what we got. Okay. Delay time looks... weird. I don't know what we're doing. What's wrong there? Alright, let's stop. Alright, what are we? We're not our... Okay. What did we do wrong here? Set everything up here. Everything should be set up. Our voltage is not... oh, it's such a... okay. I think this is backwards here. So 0.15 divided by 65550. That's delay val. Let's try that a little bit. Now we're functioning. We had such a long delay time. Okay. Alright. So our voltage is working. let's we'll leave it at that. Because now we need to change, since I said this is brute force, we know our circuit works. So to make it cycle through, we need to do this over and over and over. And then, so we'll take actually this, control and copy. All right, and then let's do that. So we need 1, 2, 3, 4, 5, 6, 7, 8. 8 of these total. We'll have to go back through and change as we go. All right, so that's 3, 4, 5, 6, 7, 8. All right, let's go back. We're going to copy this here. Control C. But for this one, we want to have that off that turn. And now we Control V. So our first one will be lit, and the rest will be off. The second will be lit, the rest of them will be off. And now we need our, put our 0 in there. And here, our third one. And here, fourth one on. And we need our fifth one on. And then it's going to go back to 4. To go back the other way. 0. Oh, and then the third one. Back the other way. Let's make this one 0. And then our second one back. That's our last one, because then it'll go back to the beginning where we have number 1 lit. So, alright. We got 1, 2, 3, 4, 5, all those, and we're controlling DT, delay time, with this formula here. And so actually, yeah, what I showed you before, that wasn't actually quite, we should have, that should have been the other way around. I should have did that light different. So that formula was slightly wrong, doing it that way, and I apologize. I should have went through the math and did it out instead of taking shortcuts. I'll probably get admonished by Paul for that. But it did the math. I just didn't show it, and I explained it wrong on the other one. But, so we should, let's see if we get it. Let's run, hold our breath. Goes over, back and forth. Let's see if we can control the brightness here. Go down. It's getting dimmer. It's harder to see on camera, dimmer. You can see it's barely lit there. Control the brightness. Bring the brightness up a little bit there. Now let's slow the delay time down. So because all the way to the left is the maximum delay time. Just like this, all the way to the right is maximum. Just like the dimness, all the way to the right is brightest. So as we go left, our delay time will get shorter cycling through, and the LEDs will go cycle through faster and faster. You can see I'm already speeding up. And down here we're at about 0.1. Down into 0.9 delay time, 0.8, and they're starting to go pretty fast, 0.6, 0.5, going really fast, 0.4, 0.3 and 2, Going really fast, 0.1, all the way down to 0, where it looks like it's just about, it's going way fast, and it's also spamming because it's delaying and printing so fast. And we can also control our brightness here. See them getting brighter and brighter and brighter. And that's up full brightness. Now let's slow our delay down. It goes slower and slower all the way till we're at 0.15. And if we wanted to change that, say we wanted it at 0.25 for it even slower, we could do that. Let's stop. Start it. See how slow that is? It's almost 0.25, 0.22, 0.7, 0.14. It's getting faster. And it'll go all the way down to 0 again. Really fast there. Even though the frame rate can't keep up on the camera there, that's a little better. I had to bump it up to 0.019, almost 0.02 for the camera to pick up. But anyway, we bring it all the way up. And that was our old value, right about 0.15. And go all the way up, and it's down to basically 0.25. So you can play with that and set it at different values. Like I said, this is a very brute force way of doing it. There's much better ways with the for loops and counters and everything, which we've done a little bit. We haven't really delved into it a lot yet. So I just wanted to show the brute force way of doing it. And we'll revisit this later on in the lessons after we have been given more tools to work with per se. But anyway, I hope everybody enjoyed it, and sorry this is so long. And I'm going to try to get some more videos out in the studio in the truck, kind of looking maybe some other videos in here. If y'all'd like to see some videos with soldering surface mount components, working on that the T41 EP, the 8-circuit board ham radio based off the Teensy, maybe I could do some of those as well. Start taking parts in the truck. I got lots of let's see if I can pull them up here. Also, so a bunch of other parts, lots of parts full of surface mount components and everything from DigiKey and many other places. Got a lot of those to solder on. I'll show you a little. I did get the I'll show this here. I did a little dusty. Got the power supply module for the board. That's one of the boards. The power supply module done for it. And I've done a few other couple things. Started on the main board a little bit. Maybe we'll do some videos on that at some point. Basically, I put some of those, see if we can get it in here a little bit better. Just a couple of surface mount IC chips on there. I still got a lot more components to go. The header, and we got other boards here. This is the power amplifier board, and this one's the low pass filter board, and we got our exciter board, the QSD. So that's got 1, 2, 3, 4. That's 5, 6. Got 2 more boards here somewhere. Let me see where. That one. I'm not gonna dig for the other one, but anyway, it's there's this switch matrix for the panel there. And I do want to kind of show these off because I'm really excited about these. These are, I'm actually going to be making a couple of these when it's all said and done. But these will be the 9-inch touchscreen display for the radio. I'll be making my own enclosure for it. This will be the 9-inch TFT color touchscreen display. I've loved this project. It's taken me a lot longer than I've wanted to get working more on it. But like I said, life's been in the way, and well, family comes first. So projects and tinkerings and all that, they come after family, because it'd be a dull and boring place without family. And anyway, I'm rambling. But that's there. And oh, and there'll also be some winding. I got a bunch of bunch of toroids. Actually, let me go to a better screen where you can kind of see this a little bit. Much the different toroids and ferrite beads and different things that'll be going for this project. So if that's something that y'all would like to see, different soldering and circuits on stuff, and let me know. Maybe I can do some videos on those as well, some progress reports or something there. But anyway, this video is already 47 minutes. I apologize. I hope everyone has an awesome day, afternoon, morning, night, whatever time it is that you're watching this. Enjoy, and thank you very much for watching. We will see y'all the next time. Bye for now.